All right, afternoon, folks. This time around, we are interested in direct and inverse proportion. This touches on IGCSE Form 3 mathematics. So we are expecting to, by end of this discussion, be able to express direct and inverse proportion algebraically. Also use proportionality relationships to find known quantities. We must also be able to correctly determine and use the constant of proportionality K and also solve real-world problems involving direct and indirect proportion, and also avoid common errors, especially confusing direct and indirect proportion. So these are the key terms that we encounter: direct proportion, inverse proportion, constant of proportionality K, variation, algebraic form. Now, just a few notes to discuss about here. One quantity varies directly with another if as one increases, the other one also increases, or both decrease at the same time. So the notation is going to be given like this, where we are saying when we say y varies with x, we expect a k to be formed in the process. So y varies directly with x, then it takes us to, that's the proportionality symbol, y equal to kx. K will come as a constant of a variation, which will bring the equality sign. Inverse proportion, when one quantity increases, the other one decreases. So there's inverse. In other words, it goes in antagonistic fashion. When one goes up, the other one goes down. So the picture will be like that. Y is proportional to 1 over x. Then if we bring equality, k goes on the numerator. So it's y equal to k over x. So inverse proportionality also involves powers like roots, you name them. T varies inverse is the square root of v. So there is a common mistake to not writing direct instead of inverse variation, or placing x incorrectly. Then also, when we are using constant of proportionality, write the correct proportionality relationships, convert to the equation using k, then substitute given values to find k. Use the formula with calculated k to find unknown values. Let's see if we can rush through about 10 problems here. Y varies directly with x, right? The relationship. So relationship is simply y proportional to x, like that. Then second problem, y is equal to 12 when x is 3. Find k. So here we said y is proportional to k. So then y is actually kx. Then we are told y is 12 when x is 3. Therefore, our k, when we divide both sides by 3, it leads us to k being 4. Then the next problem, we're interested in finding y when x is 10. But remember, our relationship is no longer kx, is now 4x. So if x is known, we can find y. Y will be 4 multiplied by 10. Therefore, y will be 40. Still moving, y varies inversely with x. Express y in terms of x. So y varies inversely. So this is 1 over x. That's the proportionality. Example, find y when x is equal to 4 to find k. So in this scenario, if we want to bring equality, we are now saying y equal to k over x, was the proportion constant k comes in. Then we are given values. Y is 5 equal to k over x is 4. And as we see, this is now an equation where we want to find k. And in doing so, our k will be equal to 5 times 4. Therefore, k is actually 20. Now, we can rewrite our relationship as y is equal to 20 over x. Then what are they saying on example 6? Find y when x is 10. So we are now interested in y when x is not. So it's 20 over 10. Therefore, our y will be 2. Now moving to number 7, t varies inversely as the square root of v. So in other words, we are saying t is 1 over root v. So write the formula for t. We found the formula. Then in example 8, and the moment we have the formula, we expect something of this nature to come, where we have root over v. Then what's the problem? If t is equal to 6 and v is equal to 9, find k. So we are saying t is equal to 6 and k over root 9. Therefore, root 9 gives us 3. So it looks like as we proceed with the calculation, the ku actually be 6 multiplied by 3. Therefore, our ku will be 18. So as we move on with our calculation, it now looks like we are rewriting the relation now that t is equal to 18 over root v. So t is equal to 18 over root v. Now we can find either v or t. Find t when v is 16. So t will be equal to 18 over, well, root v, root 16. As we proceed with the calculations, t will actually be 18 over 4. And when we divide there, it looks like it takes us to t, let's see, it will take us to t being equal to 4.5. Still moving, explain one common error in variation problems. Well, the common error that we have is um, failing to determine the correct formula. In other words, you mix up inverse and direct. So the moment that happens, then everything collapses. Thank you for the first part. We'll meet in the second series. Bye.